Hello guys, welcome back to MedZone African Motives. We are still on our mathematics for grade 11, and this is a typical exam that we are going to consider our paper 2 from this department of Gauteng province. So we are going to see, guys, how we are supposed to attempt these typical questions. That is a 2-hour paper, total of 100 marks. So it was just actually 2 hours. So we're gonna see with our time if you're able to work through the 2 hours. All right, this question consisted of 8 questions. All right, what is important is that you are supposed to show all the workings and also to round your answers to 2 decimal places unless stated otherwise. Then you're given to answer the separate questions. Okay, that one is for you guys when you're answering. Okay, so I'm not going to waste much of your time. We are working with our exams, this and that. So let us quickly rush through our question. We are given question number 1, the following box and whisker plot. We are already given, all right? And the accompanying 5-number summary shows the marks obtained by grade 11A for a mathematics test out of 50. Okay, so this is for our grade 11, which is the minimum value. We are given Q1, Q2, Q3, the maximum value. This is what you're given, and it is drawn for us. Okay, let's see what are they trying to say. From this information, we are later given the following. Data shows the marks obtained by the learners in another class, which is grade 11B. All right. For the same mathematics test out of 50, from this, determine the 5-number summary for grade 11B. So here it's like, guys, they gave you from the previous case, like what exactly you need on your 5-number summary, the minimum value, the lower quartile, the median value, the upper quartile, the maximum value. It's a hint that you have. And also how to draw, you're given that. So you're just taking the same situation on this part now. So you're given our numbers 10, 13, and so forth, up to 48. Okay. So when you are to determine the 5-number summary, as we can see, we've got the minimum value, the lower quartile, the median, the upper quartile, and the maximum value. First thing, check if the numbers are in the order of size. Are these numbers in the order of size? Is it ascending or a descending order? So in this case, these numbers 10, 13, they are in order of sizes. We can see they are in increasing order up to 48, which is they're fine. So in this case, we do not have a problem. We're just going to determine our 5-number summary. Okay, so remember from the 5-number summary, what you need. Okay, so I'm just going to try utilize this space here. So in this case, that is the first part that you're going to have. So remember our 5-number summary, we are going to need the minimum value, which is the minimum value first, and the minimum value, which is 10 according to this distribution that you're given. That is a 10. Also, you're going to have the lower quartile and so forth up to the maximum value. We're going to talk about that. All right, so the next is Q1. Also, if you have forgotten this, guys, you have a reference minimum, Q1, and so on and so on. So you're going to need the Q1, which is the lower quartile. So Q1, the first thing is to determine the position for the lower quartile. The first thing is to determine the position. Where are we going to have this lower quartile? So remember the position, it's a quarter of n plus 1. That is to determine the position. So that is 1/4 of n plus 1. How many the students are we given, the learners that you're given? So this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So they are 16 learners that we are given. This is our n. So n is equal to 16, which is the total. So n is the frequency, which is the total. So that is going to be 16 plus 1. And on your calculator, that is a quarter of 16 plus 1 is going to be something like 4,25. So this is a decimal that you're having. So a decimal, it shows us that the position is in between the fourth term and the fifth term. This is 4,25. 4,2. So you start with this 4. So you consider the fourth term and the next term, which is the fifth term, because it's in between those terms whenever you're given a decimal. So we need in between the fourth and the fifth term. So let's count 1, 2, 3. So the fourth term is 21. The fifth term is also 21. So the number is supposed to be in between these two terms, in between, because we had considered whenever you're given a decimal. So therefore, our Q1 is equal to what? The number in between these two numbers, 21 and 21. So the number in between 21 and 21 is 21 plus 21 divided by 2. So you take those numbers, divide by 2. So that was going to give you a 21 in that case. All right, so that is your Q1, which is the value representing Q1. Okay, so the first thing is to determine the position. So this is 4,25 position, but we need the exact value from there. So it's the same thing even with the Q2, which is the median value. Our Q2 is just now half of n plus 1. So in the same sense, that was going to be half of n, which is 16 plus 1, and that was going to be something like 8,5. So 8,5 again is a decimal, so it means you're supposed to consider the 8th term and the following term, which is the 9th term. So the 8th and the 9th terms, those are the ones that you consider because you are given 8,25 is a decimal that you're having there. So you're going to count again 1, 2, 3, 4, 5, 6, 7. So this is the 8th term and this is the 9th term. So you consider the term on the 8th and on the 9th term. Those are the terms that you consider, 21 and 80 and 31. So that is a 29 and a 31. So to find the Q1, you add that 29 and 31. That is 29 plus 31, you divide by 2, which is going to be a 30. So this is your Q2. That is the exact value of Q2. So that was going to be a 30, okay, which is the median value. So this is how you determine these positions, guys. I mean, these values. The first thing is the position. Where is it situated from those numbers? Then you determine that. All right. So it is the same thing with the upper quarter, which is 3. So this is 3/4 of n plus 1. 3/4 of n plus 1. Remember, your n is 16. So that is 3/4 of 16 plus 1. And that was going to be 12,75. 12,75. So the 12,75, it means the number is supposed to be taken in between the 12th term and the 13th term, the next term. So because of the decimal, if it was just a 12, you're just going to take the exact term, but the decimal means you're going to consider these two terms, the 12th and the 13th term. From what we are given, we are going to calculate up to 12 and 13. So remember, here we are at 9. So that is 10, 11. Remember, we need 12 and 13. There are numbers in between them. There's a number in between that we need between these two numbers, the 38 and what? The 42. So how do you find that number? You add those two. That is 38 plus 42 divided by 2. So that was going to be a 40. So that is our Q3 at the end. That was going to be a 40. Okay. So it's no longer a position. We are now talking about the exact value that we are obtaining. So that is what you're given. And also remember, we're going to need the maximum value, which is the end value. That is our maximum value, which is 48. So that is our 5-number summary. 1, 2, 3, 4, 5. That is what they want in your exams. All right, so that was what we had. And from this information, just like what we had before, where you were given the 5-number summary and also the box and whisker plot was drawn, this time they're asking you on this information, from the grade 11B that we are talking about, draw on this diagram provided, draw a box and whisker plot. So we are given this part where we need to draw our box and whisker plot. So remember, just like what we had on the grade 11, where we talk about the minimum value, where we talk about Q1, Q2, which is the median, Q3, and the maximum value. Those are the most important numbers that you need. So in the same sense, we are going to represent those numbers that we obtained from our 5-number summary. Remember, from our 5-number summary, the minimum value that we are given is a 10. So we are going to indicate our slope at 10, the first value, which is at 10, which is our minimum value. All right, so around 10, that's somewhere here. So you're gonna check it straight around 10. Okay, you're gonna just have a whisker. So this is corresponding to 10. This is your minimum value. Then the starting part of the box is supposed to have Q1, and the Q1 is 21. That is 21. Take note, this is 21. And according to this is 20. So you just approximate 21 somewhere there. So just gonna have an approximation 21 just above, just after 20. Okay, so you can even indicate the numbers on top so that you are exact to show this is 21. Then the other number to end the box, okay, we're gonna need Q2 and Q3. So Q2, which is 20 at the median here, which is 30, I mean, so that is 30. That is 30 then. So that is 30 somewhere. Somewhere. This is exactly at 30. So you're going to take straight at 30. That is straight at 30. That is, remember, this is your Q2 and your Q3, which is the end part to finish the box, is at 40. So 40 is there clear. You're going to take it straight. That is our 40. So we are taking these direct value, like some of these they are direct values that you are working with. So this is at what? At 40. So this is to end up our box. Okay, remember the box is made up of Q1, which is 21. So this is our Q1. This is our Q2, which is the median, Q3, which is upper quartile. So we need the last part of the whisker to finish up this, which is the maximum value at 48. So the maximum value was at 48. 48 is just below the 50. So you're just going to indicate somewhere there below the 50. Okay, just before the 50, somewhere there. Just going to write on top 48 or even down to indicate. All right, then we join to the box. We join. Okay, so that is what you are going to need at the end. So this was a direct question, guys, isn't it? It was a direct question. Already the example is there from what you're given. So it's like an example that you have. So if you do not understand, you are going to follow that example that you're given. All right, then from this information, calculate the mean mark of the grade 11, grade 11B. These ones in grade 11. This is our grade 11B. Remember, the first one was grade 11A. So remember the mean. In order for you to have the mean, you're going to add all the terms. All right, so this is it, guys. In order for us to have the mean value. So that's 1.3. So remember the mean, you can even write it in short like this. So mean is equal to the sum of terms over the number of terms. Okay, the sum, you add these terms. So you're going to add everything on these numbers. I want you to add everything, 10 plus this, plus this, plus this, up to the last one. All right, up to 48. You add all the numbers. So that was going to be 480 divided. Remember our n, when we counted these numbers, there are 16 numbers. Remember that was our n, the one that we're using on those formulas. There are 16. So this was going to give us 30. That is our mean, or the average value, the mean or the average value. All right, then 1.4, calculate the standard deviation of grade 11B. So that is, we are talking about the grade 11B, and that is 2 marks for that. So the standard deviation, you can calculate this on your calculator. Actually, they will just need an answer for that. So using your calculator, you can calculate the standard deviation, which is, okay, let me just wave the calculator here so that maybe we can see what I'm trying to say. So this is it. On your calculator, this is what you are going to do. Let me just bring my calculator to the normal mode first. All right. So you're going to change the calculator to the state mode. That is shift. Okay, sorry for that. Just going to go to the setup, to the mode like this mode, straight to the mode. Then you go to the state, which is 3. So if you press 3, on this, we are going to be given a lot of things. That is number 1, the a plus bx, and so on and so on. So us, what we need is this one, the number 1. So you press 1. So on this one, it is going to give you to input the x values that you're given. Like this is given for the ungrouped information. So I'm just going to quickly insert the values that you're given. Remember, we are given 10. So the first value is 10 is equal to, you move to another one, 13 is equal to, 17 is equal to, and so you insert those values that you are given. Another 21, we had a 23, we had a 27, we had a 29, we had 31, we had a 34, we had a 37. So you insert every number is equal to every number, press equal to every number, press equal to up to the last one. So that is how you can determine this. The other one, it was 46, and the last one was a 48. So this is it. You have inserted your values, okay? Just like this, okay? Then just cancel everything. Just press this AC button, cancel everything, then go back again you're gonna go to this shift. Okay, you're gonna work with this shift here. So it's shift, you press this button 1 where it's written state, this one, you press it. So it is gonna give you again, remember you're working with the part of VAR, this one, the variance part. So you press this one, the number 4. On number 4, you can see there's a 2 there, which is the 2 is for the mean. So if we press this 2, it is going to give us the mean that we obtain there. Let me just press it. I want you to see. Mean is equal to 30. All right, I think there is a value maybe that I just insert. Okay, the mean was 30. Okay, that is it, guys. Okay, I'm explaining 2 things at the same time. Very sorry. Remember, our mean was 30. This is exactly our mean. Okay, let's cancel again. I'm gonna cancel this. We go back to the shift to that. Sorry for that. So you're gonna shift. Let's hope I did not close up my information. So 3 is the one that we need. Okay, 3 is the one that we need for the standard deviation. So we press 3 is equal to, so it gives us the standard deviation 11,461 and so on. Okay, so to 2 decimal place is going to be 11,46. So that was our standard deviation in this case, which was 11,46. So that's how you can calculate your standard deviation. It is just using your calculator. 2 marks there. You're going to get this. Just writing the answer like that, you are going to obtain the full marks. All right, 1.5 we are given. How many learners in grade 11B obtained a mark that is higher than 1 standard deviation above the mean, which is higher than, which is more than 1 standard above the mean? So what does it mean? Remember, you've got the mean. Our mean in this case, we calculated our mean, it was a 30. So we need learners whose standard, whose like the mark is above, it is higher than. So what you do is that when it is higher than, you add these two above this. So meaning to say the mark is supposed to be the standard deviation, the one standard deviation plus the mean, because you're told it's above that one. So what is our standard? With this one, it's like a position, like which ones are we going to obtain from that interval? Okay, so our standard deviation, that is 11,46 plus 30. This is going to give us 41,46. So the question is, they are supposed to have a mark that is higher than that is above this. Above this. So we need learners who have got a mark which is above 41,46. This is our marks. Which mark is above 41? This is 38. This is 42. If we just check 42, 42 is above. So this 38 is below. All these, they are below. But from 42, it's above 41,46. So there's 42, 43, 46, 48. These numbers, they are above 41,46. So how many? The question is how many learners? This one, it's a learner, it's a learner, it's a learner, it's a learner. How many? There are 4. So meaning to say we are talking about 4 learners at the end. Okay, so you're going to calculate the one standard deviation above. Then we talk about how many are we having, which above. If they said which ones are they below, you're going to take which are less than that, but we need those ones who are above. Okay, taking the interquartile range of the 2 grades into account, the interquartile range of the 2 into account, comment on the performance of the grade 11A and 11B, taking the interquartile range. So we do not have the interquartile range. We just have these values, the maximum, this and that. All right, so let us take the interquartile range into consideration. How do you calculate the interquartile range? That is the first thing, because you have to consider it. So remember that the interquartile range, so let's start with the grade 11A. So you're going to start with the grade 11A. So the interquartile range, remember, is the difference between Q3 and Q1. So that means for the grade 11, our Q3, remember, that is 30 minus Q1, which is 11. Our interquartile range was going to be 19. Okay, that is for grade 11, grade 11A. Then let's talk about the same, but in grade 11B. So you're going to consider grade 11B. The interquartile range for the grade 11B from our formula, upper quartile minus lower quartile, which is Q3 minus Q1. Our Q3 is 40 minus Q1, which is 21. So that is the difference between these two is 19. We have got the same value. As we can see, this is 19. This is also 19. So the question is, let's get rid of the question. They will just calculate it, but the question is comment on the performance using the interquartile range. How can we conclude, that is to comment? So we can see that there is no difference. The first thing, there is no difference. There is no difference. That is the first thing in the interquartile range. So in this interquartile range, there is no difference. That is for both classes. We have got an interquartile range of what? Of 19. But however, if we are to consider in terms of the performance that happened, remember this one, the median value of grade 11, grade 11A, this is our Q2, the median value is 21. If we consider here, our median value in this case is 30. We're talking about 30 in that case. So meaning to say, for this one, which is 30, out of the learners that we have, talking of the median value, it is something that is a greater compared to what we have from the grade 11A. So you can conclude that in grade 11B, they performed better than what we had in terms of what in terms of grade 11B. So we can say that's a grade 11B generally performed better. So this one, it performed better compared to what we had before with the grade 11A. So this one, it has a better performance, okay? That is what we can conclude. All right. Determine the percentage of learners in grade 11A who achieved less than 30 for the test, less than 30. So in this case, how can we see that these ones, they have got less than 30? According to the information, remember, these are the values, the minimum, the lower. So if you check Q3 is where we have a 30. That is where a 30 is. At Q3, that is where we have a 30. So meaning to say all these, they are in within the 30. And remember, what does Q3 represent? Q3 represents the third, 3/4, the third part of the distribution, 3/4 of the distribution. So our values, they are affected. The 30% is at Q3. At Q3, that is 3/4 of the distribution. So it's 3/4 of what? Of 100%. So this is 75% of learners that we are talking about who had a mark which is less than 30%. We can take that because it's already given. It's not like something that you have to find out or that you have to calculate. No, it's already, we already have that mark. We already have, it's indicated. All right, question number 2 we are given, which is on our analytical geometry. In the following diagram, we are given the point D, the point E, the point F, and G are the vertices of a quadrilateral. The equation of EG, that is EG, this equation, we are given its equation, this line, EG, which is 3x minus y plus 6 is equal to 0. Okay, the diagonals of the quadrilateral bisect each other at the point K. So these diagonals, they bisect each other at the point K. So in actual sense, the point K is representing the midpoint of both, because they are bisecting. To bisect, that is to divide into 2. So K is the midpoint. The point F is on the x-axis and beta is the angle of inclination of the line AG. As you can see, the angle beta, the point F on the x-axis, which is, okay, no problem for that. So this is the information that you're given. And the first question was 2.1 to determine the size of beta, which is the angle of inclination. This is where our beta is, the angle of inclination of the line EG. How do you find the angle of inclination? That is the question. If I am given a gradient, let's say I have got a gradient, remember how to determine the angle of inclination. Okay? The angle of inclination, if it is beta, it is equal to arctan of the gradient of that line. The line where this beta is, it's on line EG, so it's arctan of the gradient of the line EG. Are we having the gradient of line EG? We do not have. We are just given the point G. We are not given any other point. But we know that from the equation that we are given, we can determine the gradient of EG if we are to write our equation in the form of y is equal to mx plus c. M is the gradient. So can we write this equation in that format? That is the question. 3x minus y plus 6 is equal to 0. You can make y the subject of the formula. Take y to this side. You are left with 3x plus 6, which is equal to y. As you can see, y is the subject of the formula. Writing that y, 3x plus 6 is equal to y, it is the same as y is equal to 3x plus 6. I haven't changed anything. A is equal to B, B is equal to A. There's no difference between these two. So as we can see, if we have written in the format of y is equal to mx plus c, where m is the gradient and our gradient there is 3. So meaning to say the gradient of the line EG is equal to 3. So if the gradient of the line is 3, therefore beta being arctan of the gradient is going to be our angle of inclination. So that was the idea of this question, which was going to be 71,57 to 2 decimal places. Remember arctan, that is shift tan on your calculator. So that was our angle beta. All right, calculate the coordinates of F. Okay, the coordinates of F given the equation of DF is, we are given the equation of DF. That is this DF, we are given the line DF, and we are given its equation to be taken as x plus 3y is equal to 8. And they're asking you to calculate the coordinates of F. What is F representing? F is the x-intercept. That is the x-intercept. And we do understand that for the x-intercept, y is supposed to be equal to 0 for the x-intercept. So if y is equal to 0, it's just to substitute into the equation that we are given x plus 3y is equal to 8. And at that point, y is equal to 0. So meaning to say x is equal to what? X is equal to 8. So therefore, the point F is 8, 0. Remember the coordinates x, y. That is the idea there. So you have got the coordinates of the point F, all right? So point F, that is 7, that is 8, 0, sorry, that is 8. Remember I said 8 there, that's 8, 0. All right, maybe we're gonna need this. 2.3, determine the coordinates of E. The coordinates of E, where are we having the point E? This is the point E where we do not know these coordinates of the point E, but we are given something that is important before about the point K, that K represents the midpoint. It is where these lines bisect. These two lines, they bisect each other at what? At K. So K is the midpoint, like I said. So taking advantage or taking use of the midpoint, remember the midpoint concept, you can use that as an advantage. So using the midpoint concept, you can calculate this, because we know that K is the midpoint, and we do understand that the coordinates of the midpoint, you add x1 and x2 divided by 2, y1 and y2 divided by 2. That is, K is the midpoint. So you're going to use this point, this line DF, because it's complete. We have got the point D, we also have the point F. So meaning to say the coordinate of the K, we are going to add the X value. We can just call X1, Y1, X2, Y2. That is minus 10 and 8 add together. Divide by 2, then 6 and 0 for the Y values, divide by 2. So this is the point K representing the midpoint. So it was going to be minus 1, 3. Remember, this is the midpoint K. It is the common midpoint for both. It is the common midpoint, meaning to say it is the same midpoint. So if it is the same midpoint, we are going to use this time the line GE as if you are calculating the midpoint that you are already given, which is this one. How are you going to calculate the midpoint? So in this case, the same K from, so this one, we are working with the line from the line DF. You are using the line DF. So the same K, but from the line GE, using the line GE. From the same thing, using the line GE, you're going to see that the midpoint from x1 plus x2, you're going to add, just going to call this x1 and add those two. So it's x plus 1 divided by 2. The y values, this is y, and this is 9. That is y plus 9 divide by what? Divide by 2. In terms of x and y, this is the same K, the same midpoint, because they're saying is the common midpoint. So what does this part tell? It tells us. What does it tell us? It tells us this can be equated, the x value to the x value. From this one, the x value is minus 1. From the same K, the x value is x plus 1 over 2. So you can calculate x. cross multiply. 2 times minus 1 minus 2 is equal to x plus 1. So transpose, that is minus 2 minus 1, that is minus 3, which is our x. From the same concept, the y values, the y value of k and this y value of k, they are supposed to be the same. So the y value of k here is 3 is supposed to be equal to the y value of k, which is y plus 9 over 2. So cross multiply, just like the previous case, 3 times 2, 6 is equal to 1 multiplies y plus 9. So that means we can determine the value of y, which is 6 minus 9, that is minus 3. So y is equal to minus 3. So this is the x value, the y value at point E. At point E, this one that you want to calculate. So therefore, the point E can be given, can be written as, remember the point x value, which is minus 3, the y value, which is minus 3. So therefore, we've got our point E. Just like that. Using the midpoint concept, you're going to calculate the point E. All right, then we are given on 2.4, prove that DGFE is a rhombus, 3 marks for that. All right, let's see. We want to prove that DG, all right, that is from D to G to F to E, this all quadrilateral that you're given, that it is a rhombus. How can we prove that it is a rhombus? What are the properties of a rhombus? What do you consider? A rhombus is a parallelogram with a pair of adjacent equal sides, the sides that are equal. So that is the properties that we have on a rhombus. So that is, in this case, the diagonals already we are given that they bisect, we are given the midpoint. So already this is given. Diagonals bisect each other. We know that they do bisect each other on a rhombus by diagonals. Okay, so you're gonna just have diagonals bisect each other. Okay, already we are given that. Okay, this is something that we have already given that we proved before. So what is it that we can prove? These diagonals, they are supposed to bisect each other and being perpendicular. That is, for these to be a rhombus, they are supposed to be perpendicular. So what we can prove that truly it's a rhombus, these diagonals, they are supposed to be perpendicular. So prove that these two lines are perpendicular. DF is perpendicular to EG. Can you prove this? If you can prove this, therefore we can conclude that it is a rhombus, because we know that diagonals, they bisect each other perpendicularly at 90 degrees. So can we prove that DF and EG, they are perpendicular? For two lines to be perpendicular, the product of their gradients should be minus 1. The gradient of this line EG, we talked about this gradient of EG when we made that the subject, y the subject, when you wanted to calculate beta, remember, we said the gradient there is 3. So we are going to find out about the gradient of the line DF. The line DF, we are given its equation. Remember, x plus 3y is equal to 8. So from this equation, let us find out what is the gradient of the line DF. Remember the equation of the line DF, we are given that x plus 3y is equal to 8. Let's make y the subject. 3y is equal to, transpose the x to the other side of the equation, it becomes a minus, that's minus x plus 8. We want to make y the subject, so we have to get rid of these 3, that is multiplying, divide by 3, by 3, by 3, each and every term. So y is equal to what? There is a negative 1, so it's the same as negative 1 over 3x plus 8 over 3. We are not worried about the y-intercept. We are worried about the value that is affecting our x, which is the gradient. Remember, if we are to write this in the form of y is equal to mx plus c, m is the gradient. So we have got the gradient of the line df in this case. The gradient of the line df is equal to minus 1 over 3. Using these gradients, can we prove that these two are perpendicular? The product of the two lines must be equal to a -1 in order for these to be perpendicular. So we are going to multiply the gradient of df to the gradient of EG and see what's going to happen. The gradient of df is -1/3, and that of EG is given as 3. So if you multiply these two, you obtain a -1. Guys, this does not just happen. It cannot just happen that you multiply the gradients and you obtain a -1. It is a clear indication that these two lines are perpendicular. DF and EG are perpendicular to each other. And if they are perpendicular to each other, therefore, we can conclude that this is a rhombus. Remember the properties of a rhombus. So therefore, you can conclude DGFE is a rhombus. So this is a rhombus. That is the diagonals. So in this case, we're talking about the diagonals bisects. All right, the diagonals bisects each other at what? At 90 degrees. Remember, the first thing is that these diagonals, they were bisecting each other. So we want to prove, are they bisecting each other at 90 degrees? By proving that they are bisecting each other at 90 degrees, that is a rhombus. That is what we can conclude. So different reasons, I do not know which one that we're going to use to prove that it is a rhombus. Let us know about your like what you think, your reasons, and what you can conclude to say truly this is a rhombus at the end. Okay, so these are the typical questions. Question number 3, again, analytical geometry. We're given in the diagram below. A is the point, -2, -1, the point B, the point C, and also the point D. So these are the points already given on our diagram. So on this diagram, we are given the first part of our question to find the length of AC in simplest form. That is in simplified said form. The length of AC. All right, this is our point A, this is our point C. Remember the length from the distance formula. Okay, that's 3.1. So the length of AC, we're going to take it from the distance formula. That is x2 minus x1 squared plus y2 minus y1 squared. So using the point AC, just going to call x1, y1, and this will be x2, y2. That is x2 minus x1. So this is AC is going to be the square root of x2, which is 1, minus our x1, which is -2. So just going to have this on your calculator, minus and a minus, that will be a plus. Okay, plus y2 minus y1, the y value is 5, minus the y1, so it's 5 minus -1, which is going to be a plus. So that is going to be 5 plus 1 at the end squared. So that was going to give you the length of AC. So simplify this properly, guys, on your calculator, or you can have this. This one was going to be 3 squared, and 3 squared is 9, 6 squared, which is 36, and if you add, that was going to be a 45. Okay, so that is in said form, or in simplest said, that is going to be 3 square root of 5. Just use your calculator. You're going to have your answer in the simplest said, 3 square root of 5. The gradient of BC, determine the gradient of BC, that is 2 marks, the gradient of BC. So we are given the point B and also the point C here. Remember the gradient, we can determine this using the gradient formula. All right, so in this case, we're just gonna name our points. Remember, we need the gradient of the line BC. So you're just gonna call x1, y1, and x2, y2. So that is 3.2. So the gradient of the line BC, the change in y over the change in x. So that is y2, which is 5, minus y1, that is a 4, over x2, our x2, that is 1, minus x1, which is -3. So that was going to give us the gradient of the line, which was 1/4. That is the gradient of the line BC. Determine the value of y if B, C, and D are collinear. We need the value of y if these are collinear, B, C, and D. Already we calculated the gradient of BC. What is it about the collinear? We are supposed to obtain the same gradient throughout if truly these points are collinear, B, C, and D. If truly these are collinear, it means they're supposed to have the same gradient. From B and C, the gradient is supposed to be the same as between C and D. It is supposed to be the same between B and D, whatever that you use, as long it is from the line BD. Whatever that you're going to take there, you're supposed to have the same gradient. So you can take advantage of the gradient that we calculated between BC. Already we calculated the gradient. So this is the idea of the collinear. So the gradient of BC, remember, we got 1/4. So we are going to use any of these points, any that you want. You can choose B and D. You can, where there is Y, which means D can be taken to, this point D can be taken to B, or you can use point D and C. It's your choice. That one is your choice. So I'm going to use C and D. So I want you to prove with the B and D, if you're going to have the same answer, you're supposed to have the same answer. So we are going to calculate the gradient of BD as if we do not have. Already we know that the gradient is supposed to be 1/4, but we are going to calculate it in terms of Y. Okay, so let's calculate the gradient of BD, which is this DB, is the change in Y over the change in X. So you're going to subtract the Y values, Y minus 5, the X values, that is 5 minus 1. All right, so Y minus 5, that is Y minus 5. You can't subtract that. 5 minus 1, that is a 4. So this is the gradient of BD, or the gradient of DB, which is the same as the gradient of BC, which is the same as the gradient of C. So whatever part that you want. So if these two are the same, we can form an equation because we are saying they are the same, they're equal. So therefore, we can formulate an equation from that. That is 1/4 is equal to Y minus 5/4. Because we're saying they're the same. So you can cross multiply, which is fine, solve, or I said, guys, if the denominators are the same, it's an equation. The denominators are the same. So automatically the numerators are also the same. Y1 is equal to Y minus 5. That is automatically these two will be equal because the denominators are the same. So Y is equal to what? 1 plus 5, that is 6. So Y is equal to 6. That is what you're supposed to obtain there. Just like that. Using the gradient concept, they are collinear. All right, anyways, if H is the new point such that AH is perpendicular to BC, determine the equation of AH. Okay, H, there's a point H that we do not know, but we need a concept where these two are perpendicular. AH is perpendicular to BC. Remember, this is our line BC, but they are saying, take note here. AH is perpendicular to BC, A to H. This is the point A here. To H, we do not know where H is, but they are saying it is perpendicular. It is at 90 degrees. Determine the equation of AH. Remember, we have got the gradient of BC, this one, 1/4 that we calculated before. What is it about two lines which are perpendicular, since we need the equation? What is it about two lines which are perpendicular? The product of their gradients, remember, is supposed to be -1. These two lines, they are perpendicular. AH is perpendicular to BC. Therefore, it means the gradient of the line AH times the gradient of the line BC must be equal to -1. We can take advantage of the BC. We have that one. We do not know the gradient of AH, but we know the gradient of BC. We calculated this one before. Remember, the gradient of BC was 1/4. So you can calculate the gradient of what? AH. Divide by 1/4, divide by 1/4. So this can cancel. That means the gradient of AH is equal to -1 divided to 1/4. That is going to be a -4. Having a gradient on AH and a point, because A is on this line, it is enough for us to determine the equation, because we also have the point. You are given the point A, which is part of your line, -2, -1. So this is enough for us to obtain the equation of AH, because we've got the gradient. So therefore, the equation of the line AH from the y is equal to mx plus c, where m is the gradient and our gradient is -4. That will be -4x plus c. Substituting the x and y value into this equation, y is -1, where x is -2 plus c. That is the product of these two was going to be 8. Transpose it to the other side. That is a -8. -1 minus 8 minus 9 is equal to c. That is the idea there. So therefore, our equation was going to be equal to, y is equal to -4x plus c, which is a -9. So this is the equation of the line AH. Just like that. That is what you needed. All right, so that is what you needed from this question, which is our question number 3. So you're going to consider other part of our question, which is question number 4. All right, let me just remove this. We need our question number 4, guys. We still have a long way to go. All right, anyways, guys, you know, this software, sometimes they just tend to misbehave. So I just need to clear up 1 or 2 things so that it does not affect us at the end as we are doing our revisions. We do not have any disturbance that we're going to have at the end. All right, so this is it, guys. Let's see. Question number 4. In the diagram below, P is a point such that OP is 25 units. All right, OP. And you're given this point R and ROB, which is beta, and beta is in this interval 180, greater than 180, but less than 270, meaning to say we are talking about 180 to 270 degrees in the third quadrant. Remember from your quadrants concept, guys. Okay, so that is what you're given. And with this information, calculate the value of x. All right, so remember, P is a point that you're given, and this can form a right-angled triangle if you were to take it down to this point. This is P, which is the x value from this point to this point. This is our x, and the y value, y is a negative down here. Y is -24. It simply gives us like the distance. So this is a right-angled triangle, remember? So you can use your Pythagoras theorem to determine the third side. You're given 2 sides. So determining or obtaining this hypotenuse, which is our r in this case, it was taken as r squared is equal to x squared plus y squared, which is the hypotenuse. So the hypotenuse is 25. 25 squared is equal to the x and y, that is x squared plus the y, which is the -24 squared. So simplifying this was going to give us 625 plus x is equal to x squared plus this, which is 576. Take it to the left-hand side. That will be a minus because it was a positive. So it's going to be a minus. So you subtract, you obtain 49. So to obtain x, that will be the square root. So x is equal to the square root of 49, which is plus or minus 7. But where our x is situated this side, on the left side of our Cartesian plan, it is a negative. So this x is supposed to be a -7. So we are referring to this side as a -7. If it was on this side, it was going to be a +7. But where our x is on the left side is a -7. Determine without okay, determine the value of each of the following without the use of a calculator. We do not need a calculator to find the sign of beta. All right, so the sign of beta, we can simply determine it direct because we have got our triangle, which is complete. Remember, the sign of beta is going to complete or to satisfy the conditions which falls in this triangle. Take note about your trigonometry, guys. Just go through your revisions, the introductions. So from the ratios, our mnemonics state that we've got the soccer to our concept. That is the soccer to our where the sign is opposite over the hypotenuse. So from the opposite over the hypotenuse, we can fill in according to this angle that is inside of the triangle. This is the opposite side of minus 24. So we've got the opposite and the hypotenuse does not change, which is the 25, the one that always faces the 90 degrees is your hypotenuse, this one, which is the 25. Just like that. Then we are given to determine the cos of 180 minus beta. Remember the cos of 180 degrees minus beta from the concept that we work with of the angles. Remember, we talked of the quadrants, that in the first quadrant, we talk of the theta. In the second quadrant, we talk of 180 degrees minus theta. The fourth quadrant, 180 degrees plus theta. The third quadrant, the fourth quadrant, which is the 360 degrees minus theta. So we've got the first, second, fourth, third, and the fourth. So the 180 degrees minus beta is the angle 180 minus theta. It is an angle which lies in the second quadrant. That is our understanding. It is an angle which lies in the second quadrant. And in the second quadrant, from the cast concept, we do understand that this is the quadrant for sine, not for cos. So cos is affected there. The cos of 180 degrees minus beta, cos 180 minus theta, because of the quadrant that we are referring to, it is equal to the minus cos of that same angle, which is beta, the acute angle. If it was theta, it is minus cos theta. That is from, remember, from our reduction formula. Cos 180 minus beta is same as minus cos beta. So we can determine this cos beta from our diagram. From our diagram now. The cos of beta adjacent over the hypotenuse. So according to this, we've got adjacent, and remember our hypotenuse. So meaning to say it was going to, the minus here is from the reduction formula. Then you write the ratio for cos beta. The ratio for cos beta is adjacent, which is minus 7, over the hypotenuse, which is 25. So this minus is from the ratio. The first one is from the reduction formula. So it was going to give us a positive 7 over 25, negative. That is a positive at the end. Just like that. So we have got the cos of beta. From that, we have got the cos of 180 degrees minus beta. Then we also have got the tan squared of minus beta. Again, we can use the concept of our angles, but the advantage of a square is that when you square anything that is negative, it becomes a positive. So this was a tan squared of minus beta like this. So this means tan minus beta like this, everything being squared. That is what it means. But remember, tan minus beta, this one is a negative angle, minus theta, which lies in the fourth quadrant. And in the fourth quadrant, it is a quadrant for cos, not for tan. So meaning to say tan minus beta is same as minus tan beta. But it is being squared. The negative squared, it's a positive. So that means we are left with the tan beta squared. The negative is no longer there. A negative raised to the power of 2 is a positive. So what we just need is the ratio of the tan. Remember, from this, the tan is opposite over the adjacent. So according to our diagram, we can bring in our ratio. Opposite, according to this angle, this is the opposite, which is minus 24 over the adjacent. Remember, our adjacent is negative 7. So that is, remember to square everything. That was going to be the tan squared minus beta. There is a squared, yes. But use your reduction formula of negative angles, you obtain minus tan beta. The minus tan beta is being squared, so a negative squared is a positive. Then you take the ratio after. You bring up the ratio after that. That is when you bring the ratio. Then you can square it. That is 576 over 49. Just like that. Okay, so that is what you're supposed to have. But if you understand this, guys, there's no need for you to even do all these. All right. So there we are. That is what you're given. And later on, you're given 4.13. T is the point on OP such that OT is 15 units. T is a point on OP. T is a point on OP. This is our P. Remember, we had the triangle, this and that we had. So they are saying there's a point which is given or which lies on P. And this point is given or is given as T. It lies on this line or OP. And let's just say this is where our T is. Okay, it lies on this point T. It lies on what? On OP. It is on OP. It lies on that. And OT is equal to 15 units. Remember, OP was 25 units. But this time, from O to P, just from O to P, it is 15 units. That is what you're given. OP is 15 units. Okay, that is what you're given there. Then the question is, show that the point T is given as this one without the use of a calculator. The point T. The point T is given. The point T. Okay, so how can we determine the point T? We do not know this point T. Okay, so this is the idea. The point T is given as x1, where we do not know the value of x. But if we are to take it back like this, on this point T straight up, it is still forming a right angle triangle, the same as what we have. And these two triangles, they have got something that is common, which is the angle that is inside of the triangle operating from beta, the beta that we had. Operating from the beta that we had before. The same properties of beta that were affecting this bigger triangle are the same properties of beta that will affect this small triangle that we have formed. We are forming a triangle there. So the x is simply the distance from O to this point. This is our x. The y that we are talking about is the y going down, which is the distance of the y like this. So meaning to say we can use the same properties that we had, the same, because it is the same beta. So it has the same properties. When I'm talking about the same properties, I'm talking about the same, we must have the same ratio. We must have the same ratios of what? Of beta. The tan, the cos, the sine, they're supposed to be the same. So taking that as an advantage, we can take that as an advantage. We have got the hypotenuse. We have got the hypotenuse, which is already given, because we are told from O to T, it's 15. And 15 represent the hypotenuse. So we've got the hypotenuse. Remember, according to this angle, Y is the opposite. So Y represents the opposite. X is the adjacent. So which ratio? Let's start with X. We can start with X. If it is possible, if there is a ratio, then you have to consider that. Is there a ratio that consider X, which is X is what the adjacent? So we go back to that SOHCAHTOA concept. X is the adjacent. So let's focus with X. X is the adjacent. The OT that we are given, this distance is along the hypotenuse. Is there a ratio which uses adjacent and hypotenuse? Forget about the Y at this moment. Forget about the other side. Just think of what you're given. Adjacent and hypotenuse. Yes, there is a ratio cos. So the question is, are we having a ratio of cos before, or have we calculated this? We did not calculate, but along the calculation, we talked about this ratio, but we can even formulate it from that bigger triangle that you are given, since we are focusing with the cos. Remember the cos of beta from this bigger triangle that we had, it is adjacent of hypotenuse. What was the adjacent this side? Remember, that was your adjacent this side, which was 7 minus the whole of this side. It was -7. Remember before, the cos of beta, it was -7, and the hypotenuse of the bigger one up to OP, it was 25. You use the original. This is from the original information that you're given. This was our cos beta. So now you ask yourself, because you are supposed to have, remember I said they maintain the same ratios of beta. So meaning, say, from the same beta, we are supposed to have the same ratio of the cos beta, but using this small triangle, which is taken up to the point T, which is taken up to the point T. Cos, what is the ratio for cos? Adjacent over hypotenuse. According to this, what is our adjacent? Our adjacent is the one that we want, which is X. So that is X over the hypotenuse, which is what? 15. These two, they are the same. We are talking about the same beta. There is no way that the same angle, we talk about the sine of 30 degrees. The sine 30 is the same. It cannot be sine 30, we write sine 30 as 0, it's the same. There is no other sine 30. So the same cos beta, which was this as -7 over 25, it is the same when it is written as X over 15. So from there, we can take an advantage to say these two are the same, they're equal. So from there, we can form an equation and solve for X because they are equal. X over 15 is equal to -7 over 25. There is no way we can have different ratios. You can cross multiply, it's up to you, or you can just get rid of this 15. It is in the denominator, so how do you remove this? You multiply by 15 both sides. That's, you have removed 15 in the denominator. So simplifying this, -7 over 25 times 15, it was going to give you -21 over 5. So you have got the X coordinate, the X value. You move on to the Y value, do the same thing. All right, we are done with this X. We are going to move on to the Y. Y is the opposite. So you ask yourself, which ratio am I going to use where there is opposite and hypotenuse? These are the two things that you're given. Opposite, which is the one that you want to calculate, which is Y. The hypotenuse you are given, which is 15. Which ratio is the ratio of sine? Am I having a sine beta that I calculated before, or I can calculate it if it is not given? Are we having the sine of beta before? Yes. Remember, we calculated the sine of beta. That was our first question. The sine of beta, remember, it gave us -24 over 25 from those calculations that we made. It is the same as the sine of beta that we are going to have considering this small triangle, which is taken up to the point T. What is the opposite? Remember the ratio for sine. Opposite over hypotenuse. The opposite, that is Y. Over the hypotenuse, this time our hypotenuse is 15. There is no way, as long it is the same beta, these ratios, they are the same. So you can form an equation. Y over 15 is equal to -24 over 25. So just like the previous case, I said you can remove the 15, which is dividing, by multiplying by it both sides. By multiplying by 15, this side, we are going to obtain the Y value, and that was going to give you -17 over 5. Thus, we have the X and Y value at point T. Remember, we need the coordinates at the end. So therefore, our point T with the x value minus 21 over 5 minus 72 over 5 as the y value. Just like that. So this is what you needed. So actually this question, it extended your knowledge of trigonometry, which is good in exams. We just need that, guys. Determine the area of the triangle ROT. All right, the area of the triangle ROT. So with this information, okay, let me just, guys, what we need, I'm gonna bring it back. Remember, guys, we calculated a lot of things, but they're saying we're supposed to calculate the area of the triangle ROT. Okay, so this is the B part of 4.13. Okay, so I'm just gonna write the B part. ROT. Okay, I removed that T, no problem, guys. Remember, our T was somewhere there, and we're given the length of OT. Remember, we were given the length of OT as what? As 15. So the question is, determine the area of this triangle ROT like this, from R to O to T like this. If you join, you are going to form a triangle like this. This is our ROT. And this triangle is a non-right angle triangle. This is the triangle that we are forming. That's from R to O to T. Remember, T is the one that we had, and the distance from O to T was 15. What type of a triangle is this? This is a non-right angled triangle. Guys, that's a non-right angle triangle that we are given. And what are the properties of a non-right angle triangle to determine the area? The area, because this is ROT, triangle ROT. So you can determine the area of a non-right angle triangle, which is half AB sine of theta, which is the angle that you're given inside. So which is going to be half of the sides that are creating the angle, which is the 15. The side OR, from O to R, we can take the distance, which is 12. That is 12 units, the Y value, the X value there, times the sine of theta. So the sine of theta, it is supposed to be the sine of this angle that is inside of the, inside here, that we are seeing here. But remember the concept about a straight line, that the acute and obtuse, the sine of this angle, which is the acute, which is theta, and the sine of 180 degrees minus theta, they are the same. So the sine of these two, they are the same. So you're going to take the sine of beta that you calculated, that one, but you use it as a positive. You're going to take the sine of beta that you calculated. Remember, the sine of beta, it was minus 24 over 25. But using this now as a positive, so you're going to multiply to 24 over 25. This as a positive, it must be a positive. Remember, it was a negative before. The sign is the same. The sign that you are having is the same. Remember, take it, guys, consider this as you were working it. Let me explain this way. As if you're working it in the second quadrant. The way that the diagram is drawn there, the way that the diagram is, don't take the way the diagram is drawn according to the information that we are seeing on this diagram here. Don't take it that way. Take it the way that we consider it. Remember, from the first and the second quadrant concept, sign is the same. So this is area, guys. We don't consider we talk about the magnitude. So just take that sign as it is, as a positive, because you're talking about the magnitude of area. So that was going to give you 86.4 square units. So this is area, which is measured in square units. That is how we could have calculated the area of triangle ROT. Just like that. All right, so the question is it the only way that we could have calculated this area? No, guys, there are so many ways that you could have used to calculate the same area of the triangle that you are given. You can consider maybe our T is somewhere here, like this. So if you formulate up to this point, you are forming a right angled triangle at this point. So you can even consider the area of the right angle triangle, you subtract the area of this one. It's going to be a lot, but you can also do that. Try and do that and see, just for the sake of revision, guys, but we're going to have a time to go back and check these alternative ways that we can actually simplify or do to simplify these questions. 4.2, simplify to a single trigonometric ratio. All right, the tan of 225 degrees, we do understand this is an angle that is in between 180 and 270 degrees, where we understand if this is theta, this is 180 degrees minus theta, this is 180 degrees plus theta, 360 degrees minus theta. So what it means that 225 degrees, there is an acute angle that was added to 180 to give us 225, which is theta. What is that angle? What is that angle? That is the question. If we are given something like, I want you to guys just remember this. If it was given like this, tan 180 plus theta, how are you going to write it? It lies in the third quadrant where tan is a positive. So you're going to write it as tan theta. So what you need is, which theta are we talking about that is affecting 225? The theta here, the angle that is added to 125. What angle was added? So how can you determine that? You simply subtract 225 degrees minus the 180 degrees. It is going to give us 45 degrees, which is the acute angle. That is the theta. So it's just like 180 plus 45. If it was tan 180 plus theta, you're going to obtain tan theta. So tan of 180 plus 45, which is the same as the tan 225, is the same as tan 45 degrees in terms of the reduced angle. So this is same as tan 45 degrees, which we know that tan 45 degrees is equal to 1. All right, so that was it, guys. Or this one, you just use your calculator, guys. This is it does not affect you. All right, the sine of 180 degrees minus theta. Sine 180 degrees minus theta. We're talking about being in the second quadrant, which is the quadrant of sine. So this will give us the sine of theta from our reduction angles. The cos of 180 degrees plus theta, talking of the core function, the cos 180 plus theta, it will fall in the second quadrant. Where it falls in the second quadrant, cos is a negative. So it's going to be a minus of the sine theta. Remember, these cos 90 plus theta, 90 minus theta, they change to a sign. But is it going to be positive or negative? You relate to how cos is in that quadrant. So in that quadrant, cos is a negative. So that's why we put minus sine theta. Cos 90 plus theta from our reduction angle, it is the same as the sine of theta. This one is your basic identity that you actually need to know. Then you are given the sine of minus theta minus 540 degrees. In this case, there's a negative and a negative. We can factor out this negative on the angle. If we factor out, this will be a positive. Factor out, this will be a positive 540 degrees. Let's talk about this first. Having the sine of minus, just sine of minus, the sine of minus beta. It is the angle that we are seeing. The sine of minus beta is a negative angle, which lies in the fourth quadrant. And in the fourth quadrant, sine is a negative. So it means it is the minus sine beta. So meaning to say the sine of minus theta plus 540 is the same as the minus sine of theta plus 540 degrees. It is in the fourth quadrant where it is a negative. But we need to reduce this until we have the acute angle, until we remain with the simpler part. 540 degrees is more than 360 degrees of a complete revolution. So subtracting 360 degrees from 540 to obtain an angle which is less than or in within the 0 to 360 degrees, we are going to obtain 180 degrees if we subtract. 540 minus 360, that's 180. So meaning to say, whenever the angle is more than 360, you subtract. Let's say it was 720. you subtract 360, you subtract this until you get an angle that is within the interval. So as we are subtracting this, we got 180 degrees. So 540, in place of this, we can replace it with what? 180 degrees. Any angle more than 360 degrees, you subtract until you get an angle which is less than or which is equal to 360 degrees. So now we can relate this one. We are used to this. The sine of theta plus 180, it is the same as the sine of 180 degrees plus theta. Which quadrant are we talking about? 180 degrees plus theta is the third quadrant, which is the quadrant of a tan. In this quadrant, sine is a negative because it's for tan. So this sine that we are talking about, it's a negative. So it means there's a negative already that we are given, but the sine that we are talking about in this quadrant, it is also a negative. It's because of the quadrant where it lies, the theta plus 180. Sine there, it's a negative. So negative, negative, it was going to give us a positive at the end. So this was going to give us a positive sine theta, a positive sine theta, and it's a product. So we're going to multiply. So this is what you needed from the first part. Simplify using this concept, and after that, you can simplify further. The tan of 45, you can even simplify from your calculator. That is a 1 positive times a negative. That's a negative. Sine times sine, it gives us a sine squared. All right, everything over sine times sine, that's a sine squared again. Remember from our identities, from the Pythagorean identity, that the sine squared plus the cos squared is equal to 1. And from that identity, we can play around to make sine squared the subject. So how can we make sine squared the subject? Because, I mean, the 1 minus sine squared to make cos squared the subject, just transpose this so that it gives us this 1 minus. That is what happened. So it means we just remain with a cos squared by transposing the sine squared to the other side of the equation. We are remaining with a cos squared. The cos squared of theta is equal to 1 minus sine squared theta. So in place of this, we can substitute with a cos squared theta. Everything over what? Over a sine squared theta. So this cannot be simplified. If we do understand this, it is the sine of theta over the cos of theta, which gives us a tan of theta. So if it is sine squared is going to be a tan squared, not a cos. A cos theta over a sine theta does not give us a tan. It gives what is called a cot. So if it is squared, it will be a cot squared. All right. So according to this does not give us a tan, guys. It gives us a cot. If you were to write it in simplest form, it was going to be a cot squared. Sine over cos. Sine over cos is the one which gives you a tan. So if it is squared, it will be a tan squared. Sine over a cos. Be careful with your identities. They are important that you do understand them. All right, so quickly rushing through, guys, because of the time, I'm just gonna rush through, guys. I never thought I was gonna finish within an hour, but now it seems like there's a lot of time. All right, question number 5. In this diagram below, we are given f of x, which is equal to this. The g of x are drawn from minus 240 to 240. Then we are given, write down the value of amplitude of g, 5.1. That is the amplitude of g. Our g is given, this is our gx with the minus 2. So meaning to say this graph was going to be taken from minus 2 up to a positive 2. As we can see, our g, according to the graph, it is taken from a minus 2 up to a positive 2. So the amplitude there is a 2. All right, so the amplitude is a 2. If you want to calculate, you can use the maximum minus minimum value over 2 concept. to have your amplitude, which is the maximum value 2 minus the minimum value, which is minus 2 divided by 2. So that was going to be a 2. So these trig functions, guys, I think we're going to talk about as a formula. They need you to just to analyze. If you understand like the basics of the topic, you see, that's why you see there's 1 mark. You don't even need formulas for that one. All right. Then the period of f. The period of f, according to this is our f of x. We are given there's a half x which is affecting there. So remember that the period is affected from the normal or the old period, which is the original period of a cos. The period of a cos is 360 degrees, something that you need to know. Now you divide to the half that you're given. All right. So this gives you the new period, which is 720 degrees. So this is the new period that you are given. You divide that value constant. Determine the values of A and P. A, where is our A? A is the value that is affecting from the cos that we are given. So you take it from the concept of the amplitude. Remember, like what we had on a minus 2, say this is 2 and this is minus, it was taken from 2 up to minus 2. But according to the graph of the cos, if you check, there is a minus half which is being subtracted. So meaning to say this graph is not going to correspond from minus 1,5 up to 1,5. It is going to correspond to a value which is below a half from what we are used to. It was supposed to be 1, then we subtract a half. So the graph is going to be taken up to a half. Then we add the minimum value. We subtract our minimum value, which is minus the minimum value, which is at minus 1,5. So, okay, so it was minus, so and it's now a positive. So if you divide, this is going to give you a 1. But according to the graph, the way the presentation is supposed to be like this. So if you check, the graph of a cos was supposed to be something like this in the normal sense. You're supposed to have the graph of cos taken from the positive like this. So it was supposed to start like this. This is what we are used to. But it's no longer maintaining that. So meaning to say it's not at positive 1, it's a minus. It was taken from the positive to down. It was taken down. It was like just like the sign that you are giving. You see the minus 2. The graph of sign was supposed to be like this in the normal sense. But now it's starting in the negative. So it affects this value of A. So that's why our A is supposed to be a negative there. So our A was supposed to be minus 1. What about P? The P is the shift that happened on the original graph of sine, which is this one. So it shifted from its original point to 60 degrees. So meaning to say, when going to the right, you are going to take it as a negative. So P is shifted. So it's going to be minus 60 degrees. All right. So guys, this one, I'm very sorry. I just need a time where I'm going to explain these functions separately. 5.4, for which values of x is the product of f of x and gx less than or equal to 0. Where the product of these two is less than or equal to 0, it means one of the function is supposed to be positive. Another function is supposed to be a negative. If f of x is positive, gx must be negative. If f of x is negative, gx must be positive. So it is happening. Where is it happening? If you check from minus 240, here we are moving, both are in the negative. Both are in the negative. Up to 120 here, both are in the negative. But the moment you move from minus 120, it is the g which is positive. Whereas if you take down here, your f is still in the negative. One is positive, one is negative from minus 120. We move up to 60. At 60 degrees, both will be positive. I mean, at 60 because this is at 0. The moment you move from that 60 degrees, you see that both functions are now in the negative. Both are in the negative. So this is wrong. This is wrong. The only region where one is positive and another one is negative is from minus 120 up to negative 60. One is positive, another one is negative. So this is the interval that you're going to take from minus 120. So you can just write x is greater than or equal to minus 120, less than or equal to 60 degrees. 5.5, we are given if hx is equal to the 2 cos x plus 30. Okay, that is our hx. And we're given that hx and gx are supposed to be equal. Write down the possible value of k for these two to be equal. Okay, if hx is given, remember, for these two to be equal, they must be at the point of intersection. So we are told that our hx this time is to be given as 2 cos x plus 30 plus p. So the p, it can be at the point of intersection with our gx. Remember, our gx, it was affected at 60 degrees minus 2, the sine of x plus p, and our p was at minus 60. So these two, they can intersect at 30 degrees. If you are to consider a shift of 30 degrees on this p, it can affect at the end the shift of p of 30 degrees. So our p can be at 30 degrees, but the p is represented with the k this time. So it can be shifted up to 30 degrees, but taken to be opposite. So it can be a positive 30 because it's opposing. So that is what we had. So guys, I'm going to find time to explain about the trigonometric functions, in fact, all the functions, so that you understand me much better, because the idea of a trig function, it just needs some basics. By just looking into the question, you can answer but looking into the question, just looking into the question, this is what I'm trying to say. You can answer the questions on trigonometric functions. Question number 6, you are given a candle holder is made in the shape of a hemisphere where a conical section is drilled out for a candle wax. Okay, so these are the properties that you're given about that. So it is a hemisphere where we are given represented by the radius. So from S to T, this is the radius of the hemisphere, which is R. And we are also given VT. From V to T, it is also represented, or it is also given as R. The radius of the cone is represented by the small letter r, which is the radius of the cone. And TW, which is TW, where TW is r, which is the radius of the cone. Okay. The angle at the vertex of the cone is theta, at the vertex here, which is theta. Remember the properties of a cone. From R to this point, it is the same as from R to this point. This line TV, it bisects the angle theta that you are given into 2 equal parts. If it was 60 degrees, you divide by 2. So this is theta. So it's going to be one side is going to be theta over 2. The other side is going to be theta over 2. It is bisected by the line TV. All right, so from this information you're given, express R, which is the small letter r, in terms of r and theta. Express this in terms of, which means you have to make r the subject, or you must create an equation. If we were given maybe one of these, we're going to work with these. We are not given the formula. I mean, we are not given the numerical values. We do not even know this. Where theta is on a right angle triangle. Why am I saying it's on a right angle triangle? This is the radius. If you have to take here, we are forming a right angled triangle, which is the same also as on the other side, you are forming a right angle triangle. And we know the properties of a right angle triangle. Using the angle of theta over 2 in this right angle triangle, we're going to use half of this angle here, because we have got these two. So I'm not going to use this theta here. I'm working with the half of it. Remember, theta was the whole of the angle. This one, half of the angle. This is a right angle triangle. So R there, the small letter r is the opposite. This capital letter R here is the adjacent. Remember, according to the 90 degrees, this one, the VW is going to be the hypotenuse. We are not focusing with the VW. You focus with where R is and where R is the capital letter and the small letter, because you need these two on your equation. All right, so let's formulate. Which ratio are you going to use with opposite and adjacent from our soccer TOA concept? That is opposite over adjacent from the tan. This is the tan of theta is equal to the opposite over the adjacent. But our theta, according to the diagram, is a half angle of the theta that we had. So it is the theta over 2. This is equal to the opposite, which is our R, over the adjacent, which is R. So as you can see, this equation, it has theta, it has the small letter R and the capital letter R. What we need is to express the small letter R in terms of this. So we can just cross multiply, or just multiply by R this side, multiply by R this side. So this can cancel. So therefore, our small letter R is equal to the product of these two, which is R, the tan of theta over 2. So it means where I am having this small letter R, I can substitute with R tan theta over 2. That is what it means. They're the same. They're the same. They are equal. They are equal. All right, 6.2, show that the remaining volume of the hemisphere can be represented by this formula. The remaining volume of the hemisphere. This is our hemisphere, and we drilled this thing here, which is we removed a cone. We removed a cone. This is the cone that was removed from the hemisphere. So if we are to take, we need the volume of the hemisphere, because this is the remaining volume. So meaning to say the remaining volume is supposed to be like this. All right, so that's 6.2. Remember, the whole of the diagram is a hemisphere. So the remaining volume is supposed to be the volume of the hemisphere that we are given minus the volume of the cone, which was drilled, which was removed. Sorry for that. We removed this cone. So if we take, whenever you are given, write your answer in terms of this, analyze what is on your answer. The answer is in terms of what? That is the question. The answer is in terms of what? That is the question. So let's analyze our answer for this volume that we want, which is the volume of the remaining part. It is in terms of pi, R, which is capital letter R, and theta. So as you can see, the small letter R is not there. It's not there on our answer. This volume that we want, it must be in terms of pi, in terms of the capital letter R, and in terms of theta. Answer the question. Answer the question that you're given properly. It's in terms of what? That is the major part. All right. So from what we are given, like I said, to have this remain, because the remaining section is this part. We want this part after removing a cone. So it means we're going to remove the hemisphere. We're going to subtract the cone from the hemisphere. We have got the volume. There we are given the formula for the whole sphere. The complete sphere. This is the volume of a sphere. What about the volume of a hemisphere? A hemisphere is a half of a sphere. So its volume is half times that of a sphere. And we are given 4 over 3 pi r cubed in terms of the capital letter R. Minus the volume of the cone. We are given the volume of the cone. Already the volume of the cone is there. A third pi r squared h. And this is the small letter that we are given. A third pi r squared h. So this is what we were supposed to have. I want you to be careful. This is what you are supposed to have. Guys, I want you to be careful. This is what you are having from the exact formula. But if we check on our answer, the answer is written in terms of pi, which is fine on this one, in terms of capital letter R, which is fine. The first part, there is nothing to complain. Let's move on to the con. Pi is there, which is fine, but check, there is a small letter R, so we have to remove this. There is H, we have to remove this. So we must write this R squared in terms of R. This H in terms of R. Is it possible? That is the question. Let's get back to the diagram. All right. H is the height that we are given, which is the perpendicular height of the cone. And according to this, this is our TV. And already we are told that TV is equal to what? Is equal to R. So H is already in terms of R. So H is in terms of R. We do not have a problem. H is equal to capital letter R. What about R squared? The small letter R. Remember, the first question it was to write R in terms of capital letter R and theta. So R is there. We have this one. R is equal to R tan theta over 2. But that one, it's a squared. So to square, you must also square this. So it means R squared is equal to what? You square R to the power of 2. That is R squared. The tan also is squared. You square everything. So this is R squared. So we now have the substitutes in terms of exactly what is needed on our formula. Okay, let's simplify. A third times this. This was going to cancel. It's going to be 2 over 3. So this is 2 over 3. Remember, guys, this is 3. So that is 2 over 3 pi R cubed minus, let's substitute. This is a third pi R cubed. R squared, that is R squared. Remember, R squared can be written as R squared tan squared theta over 2 from these simplifications that we made times H, and H is equal to R. Guys, this part that we have now, it is in terms of pi, R, and theta. Exactly what we have here. These are the ones that we're given. But we need to write it in simplest form until we get this. It must be in simplest form. So already you're given the answer, so you can even figure out what happened there in order for you to remain with that part. As you can see, guys, this is no longer about the measurement, this and that. No, you're back to your normal simplifications, factorization, this and that. All right. So 2 over 3 pi R cubed, you can simplify this part. We can multiply because we've got like terms. So R squared, so that means here, so it's a third pi R squared times R. Remember, the bases are the same. You add the exponents 2 plus 1, that is R to the exponent of 3. Then tan is raised to the power of 2. So if you check on this answer here, they just factored out pi R cubed over 3. This is what they did. They factored out the common part. Pi is common and over 3. So pi over 3 and R cubed and R cubed. There is R cubed, there is R cubed here. This is the one that they just factored out. So if you factor out pi R cubed over 3, from this one, you factor out pi R cubed over 3. What do you remain with? You remain with a 2. Minus, you factor out pi R cubed over 3, this one. A third of this one. What are you going to remain with? Tan squared. So you remain with a tan squared theta over 2. So this is exactly what we were given, or what we were given on that presentation. This is the remaining volume, the volume of the hemisphere minus that cone which was removed. A cone was removed. A cone was removed. So you subtract that. But is it in terms of what you are given? That is the question. All right. So anyways, from there, we can now answer this question, which you're now saying 6.3. The cone is filled with wax and a wick. The wick is always 1 centimeter below the level of the wax, but the wick must not protrude over the level of the flat surface of the hemisphere. The radius of the hemisphere, the capital letter R, is 12. So it must not exceed that. It must not go above that, like that radius of the hemisphere. And the radius of the hemisphere is what? Is 12. So meaning to say 1 centimeter is supposed to be removed from these 12. So we are at what? 11 centimeters. The angle of the cone theta is 36 degrees. You are given theta being 36 degrees. Determine the volume of the wax that must be put into each candle holder. Meaning to say we have the volume of the cone, but that is the one that we are talking about. In this case, we are working with the cone is the one that was filled. It is the cone which was filled. And what is the volume of the cone? Because we are given this in terms of what? In terms of R. Our normal volume of the cone, remember when you substitute those R here, here we can go back here. This is the cone. Remember, you were subtracting a cone here. All this part, you were subtracting a cone. Remember, volume of a cone. This is the volume of a cone. But we substituted those R and H, this and that. This is what we simplified up to this part here. This is the volume of a cone, this one. In terms of R, in terms of the capital letter R, and in terms of theta, because they gave us an angle. In the original sense, the volume of a cone was not having R, the capital letter R. It has the small letter r. And in the original volume, there was no theta. But we can't use that because they are talking of theta. So we have to take the volume of a cone, which has got the capital letter R and also has a theta. This is the one that you're going to take. So it's a third pi r cubed, this and that. So, okay, the 6.3. So remember our volume of a cone from that formula, it was given as a third pi r cubed, and we had a tan squared theta over. This is the one that is r and theta, which are the ones that we are given here. So that was going to be a third times pi times r cubed. Like I said, there is a slight of 1 centimeter that you remove. That is 11 cubed times the tan squared theta, meaning to say you divide 36, divide by 2, which is 18. So this is tan 18, but you must square like this on your calculator. You put the tan in a bracket. You open a bracket for a tan so that you can square that. That was going to give us an approximate of 147.15. This is the volume measured in cubic centimeters. Just like that. So these questions, guys, we ought to be very, 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 very careful. We ought to be very, very careful in our simplifications of these questions. Like I said, this one is just a crash program, guys. We are just trying to crash here, crash this, crash that. But as time goes on, we just hope for the preparations of November. We're gonna have time to work with more of what is required that you are going to be working with in your syllabus that can actually help you in the revisions. As we know that our second geometry, which is the part of our Euclidean geometry, guys, it's all about the theorems. It's all about the theorems that you must consider. So this is question number 7, where we are given CD is the diameter. Okay, so we are given that CD, remember, this is the diameter. So CD is the diameter. and PC is the tangent, which is this one. It is our tangent to the circle. Okay, so there are theorems that as you are reading, just as you are reading, it's a diameter. What is that you know about a diameter? A diameter subtends an angle of 90 degrees at the what? At the circumference. This is what you know. These are theorems. This is a tangent. What we know, a diameter and a tangent, they do meet at 90 degrees, just like a radius. Because where the radius is, that is where the diameter is also given. Then you are given the chord dk is produced to P, which is this chord. It is produced to P. Then also, let's go back to the tangent. What is that we know about the same tangent? The angle between a tangent and a chord, which is this chord CK, is equal to the angle in the alternate segment, which is in the other segment, which is 40 degrees. We are just, as we are reading the information here, these two, they intersect at Q. To intersect at Q, it means there we've got vertically opposite angles. If this angle is 65 degrees, therefore there's another 65 degrees on this part. If this is 90 degrees, these are angles on a straight line. It also means this is 90 degrees. Guys, these are properties that we just go through. We are not even answering the question. Now we can answer our question. Determine with reasons the sizes of these angles 7.1. All right. So the first angle, which is on 7.11, was angle C2. All right. Angle C2, already we talked about this. Angle C2 is 40 degrees from the tan chord concept. Angle between a tangent and a chord that is equal to the angle in the alternate segment, which is creating the 40 degrees. We talked about this. So this was going to be equal to 40 degrees. And as you are answering these questions on Euclidean geometry, you can also write the reasons in short. Instead of you writing the angle between it, you can just write tan chord. So we're talking about the tan chord theorem, okay? Then 7.12, the angle K1. Also K1, I talked about this. This is 90 degrees, a right angle. That is angles in a semicircle. So there we've got a 90 degrees angles in a semicircle. So we're talking about angles which are found in a semicircle, or a diameter subtends an angle of what? Of 90 degrees at the circumference. All right, angle P1, that is P1, this angle here, this is our P1. Okay, let's get rid and see here. There are so many ways that you can use. You can find this angle, then use angles in a triangle, which is fine. Or you can consider this QCP. This one, QCP, is a triangle. And in this triangle, this line is being extended, the line CQ, to K, like that. What is the concept about this line? We know it is producing the angle 65, which is the same, and this is the exterior angle. And we do understand that the exterior angle is equal to the sum of these two opposite interior angles. The opposite interior angles, those are the ones that we are talking about there, the opposite interior angles. So meaning to say, this angle P1 and the 40 degrees, when added, they must give us 65 degrees. So if you add these two, you must get 65 degrees at the end, which is going to give us the angle P1. 65 minus 40, that was going to be 25 degrees. So the reason we are simply talking about what? The exterior angle of a triangle, considering the triangle QCP, all right? Talking about this triangle QCP. 65 is the exterior angle, and these are the opposite interior angles, all right? Remember your theorems, guys. You can answer that using your theorems. Okay, let's check the other part. Then we are asked to prove with reasons that TC is equal to QC. TC and QC are equal. We need to prove this. Okay, so let's check. How can we prove that these two, they are equal? The first thing is to consider, we are talking about this part here. This is where we have the line TC and the line QC. We know that from our triangles, if there are angles which are equal, the sides which are opposite these angles automatically must be equal also. So if we can prove that, already we are given Q1, which is this angle Q, which is TQC. All right, TQC is equal to 65 degrees. If we can prove that angle T1 also is 65 degrees, we are done. If we can just prove that T1 is, wow, okay. Consider this bigger triangle DP up to T, this one. DTC is the extended line, meaning to say T1 is the exterior angle. So angle T1 is the exterior angle, which is the sum of these two angles, the opposite interior, which is the 40 and the 25 degrees. So if we add these two, we are obtaining 65 degrees, meaning to say these two are equal. For these two to be equal, automatically the sides opposite these angles, they are equal. So therefore, we can conclude that these two sides are equal. TC is equal to QC. These are sides opposite equal angles, all right? So you're talking about sides opposite. In short, you can just write this way, opposite equal angles. They are supposed to be equal also. That is just like that. Just like that. So this is what you need, guys. Euclidean geometry is all about the theorems that you're given. Question number 8, you're given in this diagram that we have, you're given the circumference of a circle, these points. All right. Then the question is, on the answer sheet, which is just gonna use this part. All right. Prove the theorem which states that TOV, that is the angle TOV, this angle here, is equal to 2 times angle TUV, this angle here. That is, remember, angle at the center is twice angle at the circumference. Angle at the center is twice angle at the circumference. Remember that theorem. So they want you to prove that the angle at the center is twice. All right. So let's start by making constructions, joining from the circle, from the center to the point U. So in this case, we're gonna have to construct that is from O to point U, like that, okay? So you're gonna construct this extended line, okay? From this part, we can name our angles, all right? As we constructed this, O is divided into 2 angles, that is O1 and O2. So you're gonna also have U1 and U2. Okay, we do understand that using the triangle, there are 2 triangles formed, this triangle and this triangle. So we are going to work, let's work with the triangle TOU. In this triangle TOU, the line OT and the line OU, they are equal. TO is equal to OU. We are talking about what? The radius there. The radius is supposed to be the same. So therefore, automatically, this angle T is equal to angle U1. We can conclude that from what we are seeing. Remember, from that concept of the sides, these sides are equal. So the angles opposite these sides are supposed to be equal. So angle T and angle U1, they are equal. Okay, we are not worried about this for now, but we are supposed to know this, okay? So knowing that angle T and angle U1, they are equal. These 2 angles here, this angle T, okay, let me indicate here, this angle T and this angle U1, they are equal. How can we express them? It means I can write, where there's T, I can write U1, where there's U1, I can write T, whatever that I want. Okay, so this is it, guys. This angle O1 that is being produced here, the angle O1, is the exterior angle of this triangle. this O1. And from the concept of the exterior angle, remember we say that the exterior angle is equal to the sum of the opposite interior angle, meaning to say it is the sum of angle T and the angle U1. But remember we talked about this, so this is from the exterior angle concept, all right? The exterior angle of what? Of a triangle in that case. But we talked about this before, that these two angles, they are equal from the radius concept. So instead, I can write, I have to check, all right, so here it's not given. Is it in terms of U or is it in terms of T? So you're going to choose, do you want to write your answer in terms of, so since U is the common point, you can write your answer in terms of U, because this V can also be written in terms of U. So instead of writing your answer in terms of T, you must write your answer in terms of what? In terms of U, because U is the common point that you need on your answer. So instead of U using this T, you can substitute with U. Remember, T is equal to U1. So it's just like U1 plus U, which is going to give us 2U1. That is our angle O1. Okay, this is our angle O1. So in place of this angle O1, we have got 2 angle U1 like that. Okay, let's just leave it like that. Using the same idea or the same calculations that we have on this part, we are going to see that these two are going to be the same. We are going to have the same concept from what we had before, but this time on another triangle. So we are going to consider this time VU, or that triangle, or triangle or VU. In this triangle, we are going to see that the radius OV and the radius OU, they are equal. OV is equal to OU. So from that, it means the angle V and the angle U2, they will be equal. These two angles, they are equal, okay? So from that concept, let's calculate angle O2, because that is the one that we need from our calculator. We remember we are relating these two, so we must focus on those two. Angle O2 can be calculated just from the exterior angle of a triangle concept, which is from angle V and the angle U2. That is V plus angle U2. But remember, we are saying, all right, sorry for that. So remember, we are saying these two, they are equal. All right, so this, you're going to have the same reason as this one that you wrote here. So remember, we are saying these two, they are equal. So in place of the V, I can write in terms of the U, but this is U2. So adding these two, that is, I've got angle O2, which is U2 plus U2, that is angle U2. So that is our angle O2. So that is U2 plus U2, which is 2U2. Sorry for that, guys. So that is going to be 2 angle U2 like that. So this is it. This angle O1 and angle O2, these angles that we are seeing here, O1 and O2, together they formulate TOV. Together, this gives us the TOV that we are given there. Together, we are obtaining the TOV. So if I am to add angle O1, that is angle O1 plus angle O2, in terms of the U that I'm having here, this is 2U1 plus 2U2 like that. Angle O1 in terms of U, angle O2 in terms of U, and 2 is common. We can factor it out. We can factor out this angle that we are given. So in this situation, U1 and U2, they are representing O1 plus O2. O1 and O2 combined, that is our TOV. So we can conclude that this representing TOV is equal to 2 times U1 plus U2. Let's analyze from our diagram. The combination of U1 and U2 together, it gives us the angle U, which is TUV. That is our angle TUV. So this U1 and U2, that is our angle TUV. So that is truly these two, they are equal. In conclusion, we can conclude that truly this is true. It is true that this TOV is twice angle TUV. The angle at the center is twice the angle that is at the circumference. That is what you're given. All right, 8.2, that is another part of our question. Let us consider, which is in the diagram below, there are two equal circles. These two circles, they are equal. All right, with the centers O and M. So O is the center and also M is the center. All right, so M is the center of that other circle. So I'm gonna see that one. So remember that you're told that these two circles, they're equal. From O to B, it is a radius. From O to D, it is the radius. On this other circle, from M to B, it is the radius, which is, if these two circles, they are equal, it means the radius is the same. So MB and MD, OD, OB, these, they are all equal, all these sides, all right? Then we are given these chords are produced to C, and also we are given this one produced to F. AB is the tangent. So this AB is the tangent to the circle with the center at M. So if this is the tangent, and we know from the concept that M is the radius, we know that a tangent and a radius, they do meet at 90 degrees. They do meet at 90 degrees. So this angle is 90, this angle is 90. That is the concept of the tangent, the radius and the tangent. All right. Then we are given, okay, this is AB. Then also we are given that AD is a tangent. This AD is the tangent at D, that is at point D. So it is the tangent again of the same circle which is centered at M. As we can see, that is the circle at M. So meaning to say, again, we've got the 90 degrees concept there. The radius and the tangent, they meet at 90 degrees. That is what we can conclude from that. And we are given that DOB is 2x, which is this one that we are given. With this information, the first question was to 8.1, provide a reason why DOBM is a rhombus. All right, already we talked about this radius. This is, okay, so what is it? Two pairs of what? Person side, they're equal. As you can guys, from the radius concept that I was explaining as I was reading this, I was actually explaining this part. So we've got two pairs of adjacent sides equal, as you can see from our sides. All the sides, they are equal. So we've got two pairs. Remember the properties of a rhombus. So two pairs of adjacent sides equal. Okay. Then we move on to another part, which is provide the geometric reason why each of the following angles are equal to x. Why are they equal to x? This is 2x, not x. But they are angles which are equal to x. Okay, let's start with the first one. A, which is the angle A. The angle A is the angle that is at the circumference of the circle of this one that is centered at M. Remember that is centered at O. Remember the concept that the angle at the center is twice this one at the circumference. So it means angle A is a half of that 2x, which is truly x. So this is truly equal to x. That is, angle at the center is equal to 2 times angle at the circumference. Remember concept. All right, so you can just write in short, angle at the center, that is angle at center, is equal to 2 times angle at the circumference. 2 times the angle that is at the circumference. All right. Another angle is M2. Why is it that angle M2 is equal to X? Where is M2? This is our M2 here. They are saying this, they're giving us already that this is X, but they want us to have a reason. Why are we saying this is equal to X? A, B, M, D, this one, it is a cyclic quadrilateral. All the four vertices are on the circumference of a circle. So meaning to say M2 is the exterior angle. Remember that the exterior angle is equal to the opposite interior. So this is because of being the exterior angle of a cyclic quad, which is a cyclic quadrilateral. All right. Also, D1 is equal to X. Why is it that D1, this angle here, it is also equal to X? What is the reason? Okay, what can make this angle to be equal to X? Let's see. Let's try to analyze here, guys. Let's try to analyze. All right. Is there any information that I left? Okay, we are given this code. All right, produced AD, okay, M and that. Okay, no problem. No problem for that. So you must analyze what is happening between these two. All right. Let's check between these two lines that you're given. Remember, we are given that these two, they are the same. These two, they are the same. And I want us to consider something that is common that we can consider. O, B, M, D, we proved it, this one, that it is a rhombus. Let's go to the properties of a rhombus. I want you to see something that is hidden, just something small hidden there. The properties of a rhombus, they are of a parallelogram. So meaning to say, these two sides are opposite. These two sides which are opposite, they are also parallel. These two sides are parallel. Only that on a rhombus, all sides are equal. Two pairs, but they are parallel. So meaning to say, this side OD and the side BM, they are parallel on a rhombus. We proved this before. That is a rhombus. So these two sides, they are parallel. Also, OB is parallel to DM. If they are parallel, this angle and this angle, they are corresponding angles. Remember, from your F angles, one is inside of the parallel, one is outside. So this is inside and this is outside. So this reason for these two to be equal, it is because of the corresponding angles. They are parallel lines that you are considering in that case. So these are corresponding angles. Which lines are parallel that you're considering? OD and BM. All right, so OD is parallel to BM from the rhombus concept. Remember, a rhombus is a parallelogram. So if it is a parallelogram, it maintains the properties also of a parallelogram. The two sides, opposite sides will be parallel. B2, why is it that B2 is equal to X? This is B2 here. They're saying this B2 here is X. Why is it X? Remember the properties of a rhombus. These opposite angles, they are supposed to be equal. We are talking about opposite angle from the properties of a rhombus. We proved that it's a rhombus. The rhombus states from the parallelogram concept. So that one is truly equal to X. So these are opposite angles of a what? Of a rhombus, considering the opposite angles of a rhombus. In that case, this can be equal, it can be equal to X. This angle that we are seeing here, it can be equal to X from the parallel line concept. Okay, so that is how we could have answered this one. Okay, there's so many ways that you can have also remember from the OB and the DM, they are parallel. So you can also consider, because remember we said these two are parallel. So this is creating a Z. So you can consider alternate to this M2. So angle B2 is an alternate. That is the alternate to angle M2 because OB is parallel to DM. So you're talking about parallel lines. They're creating a Z at the end. All right, just like that. Then on the other hand, we are given, in this case, prove with reasons. So you're supposed to prove giving reasons that angle D2 is equal to angle C. Okay, let's see. Angle D2 is equal to, so I don't want to erase other parts so that we might need that. Let's just see. Angle D2, we want to prove that angle D2 is equal to C. Okay, angle D2 is equal to C. Okay, let's see. Our angle D2 is here. This is our D2, this part here. Okay, let's try and see. This is our D2 at this point, and this is our angle C. So in most cases, because we do not have a theorem straight. We do not have a theorem that is straightforward. So if you do not have a theorem which is straightforward, find D2 in terms of X and also find C in terms just like that. Because you do not have a theorem which is straightforward there that you can use, but you can prove by calculating D2 in terms of X. So how can we calculate D2 in terms of X? Okay, let's start with C because C is easier. Remember, angle B3 is 90 degrees, and this angle M2 already proven is equal to what? Is equal to X. So we can calculate angle C. Angles in a triangle, so it's going to be 180 minus the angles in a triangle 90 plus X. So there we are talking about sum of angles in a triangle in this case. So that will be angle C is equal to 180 degrees minus times 90 minus times X, which is minus X. So angle C2, 180 minus 90, that's 90 degrees minus X. All right, so we calculated angle C2. This is what we got. We are supposed to do the same thing. Calculate D2 and see if it is going to give us 90 degrees minus, because we do not have a theorem that states that these two are the same. So let's find D2 in terms of X. How? That is the question. All right. Let's think, guys. Let's think along the lines. Let's think along the lines. All right. Along the lines that we are given, there is angle X, which is here affecting, which is the D2. Remember, we said the whole of this angle D1 and D2, I talked about it, that it's a 90 degrees from the tangent and the radius concept. All right, I talked about this 90, guys. You see this now? I'm having a lot of things here. But remember, this is X. This is X here. All right, there's something that I explained here, guys. There is something that I explained before. All right, it was exactly this because AD is a tangent. So I explained that this whole angle is 90 degrees. The D1 and the D2 from the tangent and the diameter, which is the radius from what? From the DM. So the whole of that D2 combined, I mean, the whole of that angle D is 90. Let's just take it like that. Okay, let's see. The whole of the angle D, the whole of the angle D combined, it's 90 degrees plus X. We talked about this. So guys, please pardon me. Please pardon me. Please. Do pardon me. The whole of the D as it is the 90 degrees from the tangent and the radius there. So we're gonna just talk about the tan, a radius, a tangent, and a radius. They meet at 90 degrees. But the D is the one giving us D1 and D2. Okay? So D1 and D2 combined, they must give us that 90. And D1 is X. Remember, D1 is X. So we can write this now. D1 plus D2, this is the one giving us D, is equal to 90 degrees. D1 is X plus D2 is equal to 90 degrees. So D2 is equal to 90 minus X. Transpose that to the other side. And this is the same as our angle C2 that we calculated before. So as we can see, therefore, these two are equal. Angle D2 is equal to angle C. That is what we needed there. So, okay, let's just hope you are with me. Let's just hope you are with me. 8.24, prove with reasons again that AB is equal to BC. AB is equal to BC. How can A to B be equal to BC? They are on the same line. So what is it that you must consider if two points that the lines that you are referring, they are found on a straight line, they are not on a triangle. If it was on a triangle like this, at least you are going to consider for these lines to be equal, I must think of the angles. I must think of but this time it's not like that. These are on the same line. So you must think of the midpoint concept, something like that. For them to be equal, there's something. B must be a midpoint. B must be a midpoint of AC. So how can we prove that B is the midpoint of AC? That is what we need. Okay. Remember, we have got the condition of the line. And there are so many theorems that we're going to need. So I'm trying to save some information to your grade 11 because some is for grade 12. I'm not supposed to talk about it in your level. Where we can think of the midpoint is when we talk of that concept, a line drawn from the center to a chord. Remember, a line drawn from a center to a chord, it is going to divide the chord into two equal parts at 90 degrees. That is where we can think of a midpoint. If it was grade 11, grade 12, we're going to think of so many things there. But in our syllabus, let's think about these two. Let's think about this one for now. So to have this concept, there must be a center and a chord. There must be a center and a chord. Already, O is the center. Take note, OB is connected. So meaning to say, if I talk about OF, I'm talking about OB. It is the same line. And already O is the center. So let's analyze and see if this line drawn from B passing through O, passing through F, like that, is it at perpendicular? Because O is already the center. But is it perpendicular to the chord? The chord. And our chord is AD. Is it perpendicular to AD? That is what we need to figure out. All right. Let's figure out. We do understand from our corresponding angle, because we talked about the parallel lines before. We talked of parallel lines. OB is parallel. OB, this one, it is parallel to DM. This line extended, it is still a parallel line to DM. So it means the angle at F2 is also 90 degrees because the angle at D is 90 degrees. So meaning to say this line truly, it is at 90 degrees to the chord. Angle F2 is equal to 90 degrees and angle F2 is equal to angle F1. Okay, let's just talk about this angle F2 on its own. For this angle F2 to be 90, it's a corresponding angle to angle D. You talk about corresponding angles there. These are corresponding angles. Remember that this OB, where OB is, there is also FB. FB is parallel to that DM. And angle D is 90 degrees. They are corresponding. By knowing that F is 90 degrees, guys, a line drawn from the center to a chord and it meets at, and they meet at 90 degrees, it does not happen. I talked about that on the introduction of our Euclidean geometry. I talked about that. It does not just happen. It means these two will be equal from A to the 90 degrees, from the 90 to B, they'll be equal. Meaning to say from A to F, it is equal from F to D. A to F, it means AF is equal to FD from the line which is drawn from the center. Remember the concept, the line from the center. So guys, I talked about this. That is the reason, because my video is now too much. I thought it's just going to be exactly 2 hours. All right. So it means these two, they're equal. So let's analyze if these two are equal. How can AB be equal to BC? How can these two be equal? These are parallel lines. Remember, these two are parallel lines. There is no way. F is the midpoint. B also is the midpoint. A line through the midpoint to the second side is supposed to be parallel. These two lines, they are parallel. So B automatically is the midpoint. And with that, from A to B, it is equal from B to C. We're now talking of the midpoint theorem. So from this, automatically AB is equal to BC. So there we are talking about the midpoint theorem there. That is the idea. The line through the midpoint parallel to the second side. Through the midpoint, there is no way. If it is drawn through the midpoint, B will be midpoint, F will be midpoint. So that is the idea there. So that's what we needed to obtain 4 marks, and that is 18 marks on this, a total of 100 marks in this question paper. So we just hope for more, like I said, for our revisions as we are revising towards our November examinations, so that we can get rid of what is ahead in time. This is what we had, guys, from Maison African Motives. Till we meet again.